Hey guys, this is a recap of section 9.3 using the converse of the Pythagorean theorem in order to classify triangles by their angles. Before we get started, we did a quick little warm-up about just using the Pythagorean theorem, so in case you forgot, it's right here. C squared equals A squared plus B squared. And there's one thing that you have to remember when using this. C is always the hypotenuse. That's the longest side. It's also the side that's right across from the 90-degree angle. So in this case, x is our hypotenuse, which means that 5 and 12 are the values for a and b. So when you set this up, x squared, is going to be equal to 5 squared plus 12 squared. So 25 plus 144. And put those together. Go up here. To get this squared value gone, to get rid of that, so x is by itself, you do the square root of both sides, and then you would get that x is equal to 13. Okay, so this is just, if you already know the triangle is right, you could use the Pythagorean theorem to find a missing side. Number 2 is really similar, but instead of solving for the hypotenuse, we're solving for a leg. So when you plug this into the Pythagorean theorem, you should put 14 squared, because that's C, A, and then the other leg, x. 7 squared plus x squared. Then you're going to use the same process that we did in question number 1 to get x squared by itself, and then square root both sides so that x is alone. Okay? And we know it should be less than 14 because this is going to be the longest side. So if you get anything bigger than 14, you automatically know something went wrong. So again, this is just using the Pythagorean theorem if you already know that a triangle is right. The reason why I wanted to do that is because the new learning that we're going to do is the converse of the Pythagorean theorem. So let's say we don't know if a triangle is a right triangle. Well, if the Pythagorean theorem comes out to be true, then our conclusion is that triangle must be a right triangle. Okay? So again, if the Pythagorean theorem is true, then the triangle is right. Okay? Here are a few examples. These triangles down here look like they're right triangles, but we don't know for sure if they are because they don't have a right angle symbol. What you want to do is basically test the Pythagorean theorem. Okay? So in order to test the Pythagorean theorem, you need to first identify the longest side. And you know that longest side you're going to plug in for the value of C. Okay? Now we have a square root here. So if you're not really sure if this is bigger or smaller than 8, a couple things you could do. Just type this right on your calculator and get a decimal. It'll come out to be a little bit more than 10. Okay? So that tells me that this is the longest side, which means that it must be C. And the others would be A and B. Okay? Now, when you do out the test, you always want to make sure that you write the Pythagorean theorem in this order, starting with C. So I'm going to put radical 113 squared is equal to 8 squared plus 7 squared. And then keep on doing out your steps. Anytime you square a square root, those just kind of cancel each other out. So we just have 113. 8 squared is 64, and 7 squared is 49. So now you just want to see, well, if I add these together, is it 113? Yes, it is. So it checks out. So if it checks out, that means if this is true, then the triangle is right. And I know the right angle would have to be here because it's got to be across from the longest side. Okay? So your conclusion is this is a right triangle. Alright, part B, also have a radical in here, so I could type this out on my calculator: 4 times the square root of 95. And then compare, is that bigger or smaller than 36? And in this case, it comes out to be bigger. So this is my C, A, B. And then you're just going to plug this right into your Pythagorean theorem to test it out and see if it comes out to be a right triangle. When you do this, make sure that, just like we did over here, you put the entire value into parentheses before you square it. Okay. Okay, now, a lot of you were struggling with how to type this on your calculator. So first you start with parentheses, 4 times. Okay, once you have that, then you can start typing in the square root of 95. So this is what your calculator will show up so far. Close the parentheses for the square root, then close the parentheses that you had from the beginning. So you should have 2 parentheses. Now if your calculator does not have this one, then you don't need to put 2. Once you have that, then you can square the whole thing. So, whoops, squared, and 1520 is what you should get. Okay? Okay, then you're just going to continue on just like we did before. So 15 squared is 225, and 36 squared is 1296. So go ahead and put these two together. You get 1521. Well, this is not true. These are not equal. So the way that you represent that is by saying, nope, they're not equal. So therefore, this is not a right triangle. Okay? Now, if a triangle is not a right triangle, then there's 2 options. It could be an acute triangle, or it could be an obtuse triangle. So if you flip to the back of this worksheet, those theorems will tell you how you would know if it's acute or it's obtuse. Okay, now, if the Pythagorean theorem doesn't test out to be true, you got 2 options. C squared could be less than a squared plus b squared, and if that happens, the triangle is acute. Or c squared could be greater than a squared plus b squared, in which case the triangle would be obtuse. So these are your other 2 options. Obviously, if it's equal to, then we know that the triangle is right. Okay? If you scoot down to these questions, it asks you to classify the triangles. So this first sentence, decide if the set of numbers can represent side lengths. That's what we did with triangle inequality. We already know how to do that. So that says if any 2 sides added together, they have to be bigger than the third. So in this case, you could quickly check 38 plus 77. Yes, that's definitely bigger than 86. So this is a triangle. Once you've established that, then you can figure out what type of triangle this actually is. Again, first step, you always identify the biggest side, which is C, in this case 86. So C squared, we don't really know if it's equal to, greater than, or less than, so we just put a box with a question mark. Okay? Then we start plugging in. So 86 squared, and then 38 squared plus 77 squared. Again, that box just means we don't know if it's equal to, less than, or greater than. Then we're going to start doing these out. So this comes out to be 7,396, 38 squared, 1,444, and then 77 squared, 5929. And then you go ahead and simplify. This side's not changing at all. Now, we've down to the last step, so we actually can decide if this is less than or greater than. In this case, c squared is greater than the other side, so that means that this must be an obtuse triangle. Okay, go ahead and see if you can complete part B using the same method. Make sure when you set it up, whoops, you always put c squared first. Okay? Okay, if you go down to this word problem here, it's a little bit confusing because it's not really clear what it's asking you to do. Okay, so first of all, it tells you the distances in miles between these three cities. Then it asks, is Cincinnati directly north of Tallahassee? What do you think they're really asking you there? Something is directly north of another city. They're really asking you, is this a right triangle? Okay, so what you should be doing is test the Pythagorean theorem to see if it comes out to be true, and if it does, then the answer is yes, it's a right triangle, so therefore it's directly north of Tallahassee. Okay, so here we go. C is always the longest side, so in this case, 714. A is 403, and then 599. Using your calculator, you can go ahead and simplify those to see if it comes out to be equal, less than, or greater than, and then you can draw your conclusion. Thanks for watching. I hope that this video helped you out. If you're still confused, please come see me to schedule an appointment for some extra help. Thanks again.